Hi again. We are on lesson 2.3, second part of the lesson, starting on page 79. So this time, we've always been looking for something that was in the numerator. Now we're going to look for something that's in the denominator. It doesn't really matter. It's just a little bit different algebra. So let's come over here. We're going to identify our angle of interest, the hypotenuse, the opposite, the adjacent. I'm going to circle up, and I can see that since I've got A and H, I'm going to use cos, because cos theta equals adjacent over hypotenuse. So in the diagram, we get that cosine of 64 is going to be the adjacent, which is 66.9, over A, which is what they've put in here for the hypotenuse. I personally wouldn't use A on a diagram when I'm doing sine, because that's one of the letters, or when I'm doing trig, that just adds confusion to it. But this is what we have, so this is what we'll do. What you could do is, instead of calling this A, you could call this adjacent, and call this adjacent, and then you've taken away the confusion. Okay, and if we cross multiply, we get cross multiply means that you multiply these two things together and it equals these two things together, and this is just a 1. So we get A times cos 64 equals 7.9, and then we divide both sides by cos 64 to get A equals 7.9 over cos 64. And I'll just show you how I taught this last year, which is I've got cos 64 equals 7.9 over A, and then I'm going to make this over 1, and then we cross multiply and divide. So we get A equals, multiply the pair, so it's 1 times 7.9 divided by cos 64. But since 1 times 7.9 is just 7.9, this is just 7.9 over cos 64, which is of course the same thing we have over here, but this just might seem more familiar to you. It's just using the cross multiply and divide instead of algebra. All right, anyway, I plug this into my calculator and I get 18.0. So, and we don't have any units on this, so we don't have to remember that. Just make sure that you can get this calculation so you're knowing how to use your calculator. It's really important you have a calculator that you're going to have. I'm not going to show you on a test how to use the calculator that you're using that day. That is your responsibility. All right? And some of them are easier to use than others, for sure. Okay, 2 more examples. Determine to 1 decimal place the length of the hypotenuse of triangle PQR, in which angle PQR is 90 degrees and blah, blah, blah. All right, it sounds like I need to draw a triangle. And it's a 90-degree triangle, and the angle I have is 28 degrees. So I'm just going to sort of draw that so that this is kind of 28 degrees. At least it's less than 45, which is kind of all I can do with my drawing skills. So now I need to label it. So it tells me that angle PQR is 90 degrees. That means that it's at point Q. That's the middle letter. So this is at point Q. And angle PRQ, which is this 28 degrees, it's at point R. And what it actually means is it's the angle that goes from P to R to Q, which means that this point up here is P. That's the third point that I'm given, or vertex that I'm given for this. And then it tells me that PQ is 15.6. Okay. So identify my angle of interest, label my hypotenuse, my opposite, my adjacent, and I realize that I didn't say what I was looking for. So let's go back to the question. It says find the length of the hypotenuse. So I'm going to call this this is X, because that's what I'm looking for. And so I've got O and H, so that means that I'm doing sine theta equals opposite over hypotenuse. Sine 28 equals 15.6 over X. Cross multiply and divide. I get X equals 15.6 over sine 28. Put that in my calculator. I get X equals 33.2288497. And if I round that, I get 33.2 millimeters. And then dims, does that make sense? Is that a reasonable answer? Yeah, it's right. I mean, 300 wouldn't be right. So it's fine. Okay. One more example. We are going to find both AB and AC in this triangle. So now I'm going to label my triangle with the letters that I'm given. So since this vertex is C, I'm going to call this side C. And since this vertex is B, I'm going to call this side B. And this one is, I'm not going to bother labeling it because I've actually got the number for that one. But this way I have variables that I'm going to find. Okay. So I'm going to identify my angle of interest, and then my hypotenuse, and my opposite, and my adjacent. And then I'm going to circle, and this time I actually see I have all three of them. So I have to do a little bit of extra thinking this time. So I'm going to come over here, and the first thing I want to find, I'm going to decide I want to find side B first. So I'm going to find side B, and I put a colon there to say this is where I'm going to look up, this is where I'm going to calculate the length of side B. It tells me what I'm doing so I know why I'm writing these things down. So B, I'm going to have to use this one because that's the number I know. So I'm going to use the adjacent and the hypotenuse. So that's cosine. So cos theta is adjacent over hypotenuse. So cos 71 equals 147 over B. So B equals 147 over cos 71. And I get B equals 451.518 and a bunch of other digits. Now, the question doesn't actually ask me to find the length of B. Again, I added the B. The question asks me to find the length of AC. So I'm going to come down here and I'm go, well, B actually equals AC because that's what I was asked to find. And then I'm going to round it to the nearest meter. So this is going to be 452 meters, and that's how long AC is. And I'm going to circle that. I have to make sure I include the AC this time because I can't just give two numbers and expect whoever's marking my paper to know which one is for which. That's not going to fly. Okay? All right, and then I'm going to come over here and I'm going to calculate the value of side C. And C is opposite over adjacent. So that's, we haven't done that one yet today. That's tan. So tan theta is opposite over adjacent. So tan 71 is C over 147. C equals 147 times tan 71, and C equals 426.918999. But I wasn't asked to find C, I was asked to find AB. So C equals AB, and to whole nearest meter, that's 427 meters, and there's my answer. And it might be a good idea for me to check. So how can I check my answer? I can use my good friend Pythagoras. Okay, so in this triangle, it's going to be a squared plus c squared equals b squared. So a squared plus b, see how easy that is to do? It's going to be a squared plus b squared, no, I did it again. A squared plus c squared equals b squared. And A is 147, and C is 427, and square those. And if I add those together, it should be 452 squared. So I just put this whole thing in my calculator, and this is 203,938. Does that equal 204,304? That's close enough. anytime you're doing anything with rounding, you're going to have to decide if they're close enough. Those are actually pretty close. I could also do it with another decimal or two, and then I'm going to get an even closer number. I can, I could use this number up here for B and this number up here for C, and I'll get a closer, these things will be closer to equal, but that's not what I did today. All right, that's it. That's the end of lesson 3. Go do some practice. Remember to mark your work, and I'll see you later. Bye.